All right, so now it's time for a lab. And this is one of the first labs you're actually going to do in this course, where I provide you a packet capture, and I want to kind of have you go at it on your own and find some things that are of interest. So for this lab, I'm going to provide a packet capture that's actually HTTP communication between a client and a web server, but it's actually provided in two separate streams. We have an IPv4 stream and an IPv6 stream. Now, we've not talked about HTTP communication in detail yet, so you may not be familiar with that at the packet level, but that's okay. What I want you to actually do is compare and contrast the two streams in this capture with each other, focusing exclusively on the IP headers. So I want you to look at the stream that's IPv4 and look at the one that's IPv6, and I want you to find the packets that are equivalent. And maybe just pick one. Maybe pick the first packet of the IPv4 stream, the first packet of the IPv6 stream, and actually compare those, focusing exclusively on the network layer headers. I want you to find the things that are interesting, to find the things that are the same, that are unique, that are different, and go through that on your own first. What we'll do is in this same video, we'll pause for a moment, and you can go ahead and pause it here in just a minute, and you can go ahead and run through that on your own, and then when you're done, you can come back to this video, and I'll actually go through a couple of examples of comparing and contrasting a packet there. So go ahead and get started on this lab. When you're done, come back, resume this video, and I'll go through the lab solution. All right, so now we're going to dig into the solution for this lab, and I pulled up the packet capture file. It's http_IPv4 and 6.pcapng. And as I said, we've not talked about HTTP at the packet level, so if you're not comfortable with that, that's okay. We're not really concerned about that here. We're not even really concerned about the transport layer protocols. We're only concerned about the network layer protocols that exist in this capture. So what I want to do to compare and contrast a little bit is just get two equivalent packet. So I think the easiest way to do this is to start with the first packet of the IPv4 stream and the first packet of the IPv6 stream. Now, the first question is, how do you tell where one begins and one ends? Well, they are all together in this case. So in this case, packets 1 through 10 are the IPv4 stream, and packets 11 through 20 are the IPv6 stream. And we can tell that clearly because the source and destination IP addresses, here we have the 4-byte addresses with IPv4, and here below we have the much longer addresses with IPv6. So that's how you can tell the difference. Of course, beyond that, if I click on a packet here, I can see that IPv4 is mentioned where the network header should be. If I click on one here, IPv6 is mentioned. So we see what's going on here, and these are in order from this lab exercise I created. So we can actually just work from those. So what I'm actually going to do to compare these is I'm actually going to manipulate my window just a little bit. I'm going to go ahead and click on this first packet, right click it and say show packet in new window. So I'm going to kind of move that off to the side, and then I'm going to go down here to the first IPv6 packet and do the same thing. Show packet in new window. And what that's going to let me do is compare these packet captures. Now I've got a few other things opened up here that I want to minimize, and then I'm going to kind of stack these things up together where they're a little bit easier to compare and contrast. So bear with me just a moment. We'll go ahead and get these sorted out here. We'll have the IPv4 packet on the top, the IPv6 packet on the bottom, and I'm actually going to go ahead and just get rid of the bytes windows in this case, as I'm not really going to need them. And then I'll expand each appropriate section. So I have the IPv4 section here, I'll expand that. I have the IPv6 section here, and I'll expand that. And now we've got both headers visible, and we can actually examine both of those and compare and contrast them on the screen at the same time. Now, the first thing we'll notice, and that most people are going to notice about the difference between the IPv4 and IPv6 header, of course, is the addresses are a fair bit different. Here in the IPv4 header, we have a source address and a destination address represented using dotted quads, which is a decimal representation of the 4-byte address space. In IPv6, we have a much different notation. We have a hexadecimal notation broken up into 8 groups representing the 16 byte IPv6 address space. So it's 4 times larger of an address space, which means we have a much larger address representation as we discussed. So that's probably the biggest difference that most people are going to notice. Next are the header size fields. Now in IPv4, it's a variable length header size. So we have the header length field. So the system that's processing that data, so it knows how long the header length is and how to process that. We don't have an associated field like that in IPv6. You won't see a header length field because the header length for IPv6 is static. It's always 40 bytes, and if any additional features are needed, they'll be done with extension headers. We don't have extension headers at IPv4, so that's why that's the difference between those two, and a contrasting difference as opposed to a comparison there. Now we also have the length fields for IPv4. We have the total length field, which includes both the IPv4 header payload and the Ethernet header there. Whereas with the IPv6 field, we have a payload length, which is much different, and this is only 40 bytes in this case, so it's not referring specifically to the IPv4 or excuse me, the IPv6 header itself. It's everything after that. So that's going to include, in this case, we can see from the next header field all the TCP data that's in this packet, which in this case is 40 bytes of that data there. So we have those two fields which are operating differently, and that's a nuance. It's a little bit tricky to capture, but they are different, so you have to be aware of those fields and their different meanings. The next comparison I think is interesting is the protocol field. In IPv4, we have what's called protocol, and it tells us that the TCP header is next. In IPv6, we have the next header field, which is functionally the same for the most part, and it identifies and tells us that, again, the same value, 6, TCP is the next header. Remember, the difference here is that if IPv6 has an extension header, it would identify that extension header next as opposed to the transport layer protocol. So it's doing that and using extension headers rather than using a variable length header field like we have in IPv4. The next thing of interest is the TTL field. So in this case, we have time to live in IPv4. In this case, it's 64 hops. Down below, we don't have a TTL field. We actually have a hop limit field, which is functionally the same for the most part. It's going to be called hop limit because that's a better, more descriptive name. It's actually truly hop-based as opposed to time-based, and it's going to be the same value. In this case, 64 hops before this packet is expired, and then we get an unfortunate response back that our packet never made it to its destination. Now, a couple other interesting things in regards to what's in one packet that's not in the other. Now, you'll notice here we have a header checksum in our IPv4 header. We haven't talked about checksums in IPv6 header, and if you look down here, you'll notice you don't see one. And that's because IPv6 does not include that by default. That was seen as an efficiency gain, was that generally IP is going to be paired with a service that's more concerned about reliability. After all, IP is not meant to be a reliable protocol. So that's actually a service that is now passed on. So the buck has been passed to other services to handle the validation of the integrity of the IPv6 packet. IPv4 has a checksum to do this. IPv6 doesn't. So the benefit is every routing device that receives an IPv6 packet doesn't have to calculate that checksum value to make sure the integrity of the packet exists. The drawback is that if the packet gets manipulated or changed in process, there better be another mechanism to detect that, either at the transport layer or at the application layer, because otherwise it may go unnoticed and bad information may get passed. But in practice, that's not something you see too often, so checksum field, not a big deal to be missing when you think about modern networking. The next thing of interest is that these packets, neither one of them are fragmented. If you looked in the packet list window on the previous screens, you saw that there's no fragmentation going on here. However, notice that the IPv4 packet still has all these fields for it. So we see a fragment offset. If I expand the flag section, you see we have don't fragment and more fragments as well. In this case, don't fragment is set to 1. So we have these fragmentation fields present, even though fragmentation isn't actually being used. So that's inefficient, really, right? If we have fields and reserved data space we're having to transmit, even if there's 0, a 0 is a field, it's a data point that has to be transmitted. There's a difference between a field with a value of 0 as opposed to a non-existent field. So we're still transmitting the presence of that 0 or that null value. So in IPv6, you don't have that at all, and that's because we discussed IPv6 relies on extension headers, and fragmentation is handled based upon the presence of that extension header. So you only get the fragmentation extension header if you actually need fragmentation. And that sounds like it should be a pretty obvious concept, but all the less, it took us till we got to IPv6 to recognize that maybe that needs to be something that's completely optional. So you kind of see the elegance that is the IPv6 extension header option and the ability to only include fields if you actually need them. So that's pretty cool and a pretty neat compare and contrast of these two packets. That's going to wrap up our comparison and contrast here. You may find a few other interesting things if you scroll through the other packets. This is really going to cover most of it. You'll see some different values, but for the most part, this identifies, practically speaking, looking at the difference of the actual packet structure from an IPv4 packet to an IPv6 packet. So if you have access to IPv6 systems or want to set some up in a lab, it's pretty cool to actually sit around and play with those and then compare and contrast on your own as well. That's what I did here is I just set up two comparison systems, actually the same system, and I had a web server listening on IPv6, one listening on IPv4, and made the request out to these different devices and created this packet capture for this lab exercise. So IPv6 is coming. It's probably coming a lot slower than most of the folks who deal with IPv6 wish it was, but it's important to go ahead and understand it because you will start encountering it. And even if your network doesn't run IPv6, chances are you'll occasionally run into some devices that are running IPv6 by default that you have to be able to understand and shut off. And plenty of times, at least in a security setting, I've been on a network that shouldn't be running IPv6 and I've found some. So I've had to go in and dig into that to make sure it was not malicious IPv6 and that it was just something that was misconfigured. So you want to try your best to understand at least the differences between IP6 and IPv4. If nothing else, just to future-proof yourself and your abilities, as most networks will eventually transition to IPv6 at some unknown point in the future.